Hi, in this video we're going to solve this LeetCode problem as if I was in an interview. So I will tell you exactly what questions I would ask during an interview, and also I will try to reason speaking aloud, which is what you should always do during an interview. Speaking aloud, it's always important. First of all, because the interviewer want to know what you're thinking about. And second, because if you make mistakes while thinking, while reasoning, there's a high chance that the interviewer will tell you that you're making a mistake, which is always a good thing. It's always better for them to know that you're making a mistake so you don't write your code with that mistake. So let's start. We are given two integer arrays, nums1 and nums2. They're sorted in non-decreasing order. And then we have two integers, m and n, which is the number of elements in these two arrays. We need to merge these two arrays into a single sorted array in non-decreasing order. So basically we need to merge these two arrays by keeping the order. The final sorted array should not be returned by the function, but should be stored inside nums1. For this, nums1 has a length of m plus n, where m is the number of elements that should be merged, and then we have n elements set to 0. And then nums2 has a length of n. Okay, so in this case, we have nums2, which is 1, 2, 3. So this is the first array that we need to solve because m is equal to 3. And then we have these three elements. They are set to 0, and we have n elements, where n is the length of nums2. And we need to keep the order. Okay, so the way I usually approach interviews is right after I read the problem, I ask questions. In this case, it's pretty, so this is an easy LeetCode problem, so there are probably not a lot of questions that we can ask. One question could be, can we have like a zeros in the arrays? Even though, to be honest, I don't think, okay, here it says that we can have zero. To be honest, it doesn't really matter because we know where nums1 stops because of m. So let's look at the constraints. We can have basically any number. M plus n is between 1 and 200. Okay, this is interesting. M might, n and n might be 0. So we can have an empty array. This might be an edge case we have to take into account. And I will do the follow-up later. So after asking questions, I usually tell the interviewer what's the first approach that comes into my mind, which is usually the brute force approach. The very first thing that I say is almost always never the optimal approach, which is totally fine. So in this case, what I would say, so first of all, what's the brute force approach? What's the approach? How would we solve this problem if we didn't come up with anything else? The brute force approach is probably to just take the first elements and leave them like that, and then replace these elements with this array, and then sort the array. So if we do this, so in this case, the steps would be, we have this array, and then this, oops, I don't know what did I do. All right. So we have these two arrays. Then what we do is to replace these three zeros with this array. And then finally, we sort this array. I still like need to understand. Okay, if I do control, okay, interesting. So what's the complexity of this? These let's see, time and space. So for time, first of all, we would add this number here, and that's the n, but the sorting part, that's n log n, which means that the time complexity is n log n. Space complexity, that's we are okay. Assuming that this sorting algorithm is in place, this is constant because we like these arrays are already instantiated. Like we don't count them, we don't create any new arrays. We just probably will have some constants, some variables, but the number will be constant. So this is the first, like brute of, my brute force approach. Can we do better than this? I'm pretty sure we can. So after telling the interviewer what's the brute force approach, don't implement it. Don't spend time implementing it. Instead, try to think about a better way to approach this problem. If you cannot come up with a better approach, then implement this solution. Or even better, ask the interviewer, should I go with the, you can ask something like, should I go with this approach or you want me to think about it for some more time? Because usually they will give you the recommendation the best, that is the best for you. But in this case, we will try to think about a better approach. So a better approach would be to um, go over. Okay, let's assume for a second that we don't have to return. Actually, let's do this. Let's say we can create a new array. Okay, so we now the better approach would be space complexity. We go of probably I have no idea why it keeps running. So the space complexity is probably gonna be m plus n because we are creating the new array. And the time complexity, I'm pretty sure we can do this in a linear time. Um, let's see if we can. So let's say that we have this array and this array. Let's say that we only consider the first array as if it was like the actual array. Now in this case, we can have we can basically have two iterators, I and j, and then compare the numbers. Whichever number is, and by the way, here, sorry, here by n, I mean n plus n. Like this is, I'm using the generic n, like the number of inputs, which is probably not the best in this case. But yeah, I wanna clarify that. So in this, yeah, I'm not. It wasn't the best to take into account n. I'd say that this is probably not. This n should be probably n plus m, I guess. Um, Let's say that n is n plus m, which is totally wrong. Let's say x. All right. Well, in this case, we're using the original definition. Sorry for the confusion. So in this case, we iterate over these two arrays. So what's the smallest between 1 and 2? It's 1. So we create a new array and we put 1 in the new array. And then we move I um, to the next one. Now, what's the smallest between 2 and 2? You can probably just say, uh, let's say that if they are equal, we take the first array. So we also move I here, And then what's the smallest between 3 and 2? It's 2. So we take these two from the second array, and then we move the j, and then we do this every time. So 3, and at this point, I will be like outside this array, so we can just say 5 and 6. And then we will have, at the end, we will have I and j outside of the array. Uh, Once we have created this array, we can just copy this new array into nums ones, so into the first array. So this operation is time complexity is linear. This time complexity is also linear. However, so the time complexity is, and then I did the same mistake as before. So the time complexity is linear. So if we take x equals m plus m, then we can say that this is the O of x. All right. Now, can we do better than this? So this is something that I would probably start implementing already if I cannot come up with a better solution that is better than this one. So this might already be kind of fine to start with, but like we're talking about an easy problem. So after implementing this, they will probably ask you the follow-up question. And actually I thought that, okay, I didn't read the follow-up before. The follow-up is to come up with an algorithm that executes. So the follow-up question is this algorithm here. So in this case, we are already in the like follow-up question. I think there might be a way to do this even better, probably like the best approach, where the best approach is like a mix between these two. So we probably don't need to create this new array. We can just swap the items. Let's try to see if we can do that. So let's say we are here, and now we need the 3 zeros. All right. The first thing we need to remember, and now we probably need 3 iterators. The most important thing to remember is that the elements are sorted in non-decreasing order. Let's try to reason a little bit. We can compare this item with this item. So let's say time equals 1. At time 1, we have this situation here. Now, let's go to time 2. Time 2, like during the second execution of the probably what's gonna be a for loop, we will compare, like during the first for loop, we will compare these with these. What's the smallest between these two? The smallest is actually I'm not sure if we can do this with a constant space, but let's still try to reason behind it. Okay, let's say we keep 1 and then we move to the next item. This is already sorted. So this part of the array and everything before I is the final array. Okay, cool. Now let's go to time equals 3. What's the smallest between 2 and 2? We say that in this case we take the first array, so this is still sorted. So this remains the same. And now we have to compare 3 with 2. what we can do, hmm. So actually, we probably don't even need the K. Because what I was thinking is to put the 3 here. But actually, I think we can just swap these two arrays, to be honest. So uh, let's see what happens if we don't have K. I think that's the best way. Um, so in this case, 2 is less than 3. So what we do is we swap these two items. Okay, so we put 2 here and 3 here, and this is done in place. Okay, we don't require more space. We are keeping, like, we are just swapping between these two arrays that we already have. Cool. And then we move to the next uh, array. Now, and I actually think we don't even need J because we are using this array as just again as a swapping array. Um, so we probably just need I. Now we need to be really careful with the algorithm because we don't um, have to compare 0 and 3 because of course 0 is less than 3. Why we don't have to compare these? Because I, in this case, is bigger than, sorry, m, yeah, because I is bigger than m. Since I is bigger than m, we will just put whatever we have here in this array. And actually we need the j, because we need to know, okay, never mind. We need the j, because now that we put the 3 here, we can shift the j to the next element. Um, Now we're gonna put 5, and we will move the j 6 and I to the next one. And finally, on the 6th execution, we're gonna put 6 here, and we will have 1, 2, 2, 3, 5, 6. So I think this is the best way, like this is the optimal approach. I mean, it's very likely that it's the best approach because we are solving this in linear time and constant space. So in this case, um, so I'm not sure which one is better to implement for like the sake of this video. Sim okay, let's try. Um, we say that this is gonna be like what I would do during an interview. So during an interview, I would probably try to implement this approach. And if I have issues with this approach, I will just fall back to the better one. So this should be pretty easy to implement. This one is a little bit harder, I'm guessing, mostly because of the edge cases and everything, but we can try to implement it. So let's copy these. Let's remove this comment. We don't need this for now. Let's take this as reference. Let's clean this up and let's try implementing this. So the first thing that we need to know is what's m plus n. It's pretty easy to compute, and I will call these, I don't know, mn, m plus n. Probably mn is not a, let's say, um, yeah, let's call it mn. Also, one thing, it's so naming, it's important. However, it's more important to finish the problem in time. So if you like, don't spend too much time thinking about the best name that you can come up with. Nothing expects you to like come up with the best name because it's just an interview. You have a very limited amount of time to solve the problem. So just put what like don't call these foo and bar, but give it like a reasonable name, but also don't spend too much time thinking about the name. Okay, so this is gonna be the final array size, which is also the real size of nums, like the actual allocated size of nums1. So what we have to do is we say that I will iterate through, like, from the first element until the last one. So we will have a for loop that starts with 0 until mn minus 1, and then it increases. And of course, it's not a constant because we change the value. Cool. And now we also have j. So, okay, here we will we will end up updating nums1 I. Okay, we will always do this. Is there a case? So we will be comparing this value with this value. So let's take, okay, let's assume, let's not think about edge cases for now. So value 1 is gonna be nums1 I, and value 2 is gonna be nums2 j, where j is 0 at the beginning. I think we might, can we do this? Oh, okay, we can do this. Cool. Okay, so we have I and j, but we only update I. Okay, because from a logical perspective, this makes sense. So we will be comparing these two arrays. Now here, we need to remember to do check if I is outside of nums1, and same for j. So we need to check if j has reached the, like, has completed the iteration through the array, or I has, but like we will do that later. For now, let's assume we are in this case. So we need to compare these two elements. So if if val1 is less or equal to val2, so in this case we just keep going, continue. Else, so if we are in this case, we need to swap the items. Right. So this is gonna be like, let me think about it for a second. So we said that 2 and 2, okay, we keep 2, 3 and 2, we switch them, and then, okay, so in this case, nums1 I is gonna be val2, and then nums2 j is gonna be val1, value 1. So we're just swapping nums I, like nums1 and nums2 I and j. We're just swapping them. And after swapping them, what do? We just keep going, right? Looks reasonable. No, it doesn't, because we need to update j. So when do we update j? So okay, at time 3, we swapped 3 and 2, and then we move I. Okay, okay. So updating J is just part. Um, I think we should take another example. So okay, I did a mistake here. So my mistake was to just use the given example. What I recommend doing, which is something that I haven't done and I should have done, and I'm gonna do it now, is to come up with your example. Your example should include edge cases. So in this case, we can probably say three, five. Let's put a 7, and then a 10. And here we put 2, 5. Uh, Actually, let's start with 0. Okay, so what do we do in this case? So we swap. Okay, let's try to think about it. So here we have I is here and J is here. So first of all, we swap I and J. Cool. We keep J where it is. We just move I. So J is still less than I, so we put 1 and 3. We swap them. We move I. 3 is also less than 5. Okay. Um, Now 5 is less than 7. So we swap them. 7. It's not working. Interesting. Okay, so this is the bug. The problem here is that we also need to compare j and j plus 1. So if these two are... Oh, God. So what happened? I don't think we can do this, because... Alright, let's see. I think this works here. Um, 2. Yeah, that doesn't work. Because, like, we cannot just compare these two. Because now when we get here, 3 and 7, 3, if we just compare these two, 5 and 7, we are missing the 5 here. So what I think, um, so in this case, I think I don't think we can do it in linear time. There's a way to do this, which is always like iterate through this array and put the element in the right place, but I don't think we can do that in linear time. Two things could have happened during an interview. The interviewer didn't say anything, or the interviewer tried to help you. So instead of me, like if I was being interviewed, um, in this case, like and there are like a lot of things that an interviewer could do. Like they can just say, "You're wrong. You're doing something wrong. Please fix it." Or they can start asking you questions to help you understand that you're wrong. So, something to pay attention to when they start asking questions, think about the question. Like, really think about it. Because sometimes the questions are for you to understand that you're using a wrong approach. And by the way, sometimes it's just for, like, they're just asking genuine questions. But sometimes they want to help you. So pay a lot of attention. Um, so in this case, I don't think we can do this in constant space and linear time. We're gonna see the solution later. But for now, let's take this best approach, put it here, And let's try to do this. And also, like when you propose multiple approaches, you have to tell them why you think that this is better. Like why linear space and linear time is better than constant space and logarithmic time. Something you can ask is probably better to ask than to assume. So you can ask, um, do we care more, like in our case, do we care more about time or space? Depending on what they say, um, you choose one. If they say, I don't know, you pick one, then in this case, what I usually say is that uh, it's usually better to focus on time. Like, okay, there is not a right answer. It depends on the on the scenario, on the exact problem we're trying to solve. But in general, typical like 80% of the times, 90% of the times, like if you're comparing constant space with linear space, it's probably better to uh, save on time. So this would be a better approach. If we like, if the alternative was like, if this was, I don't know, like n squared or n factorial, even worse, these would have been way different. Actually, we have, so n plus n would be bounded to 200. So even in that case, it probably wouldn't, what's 200 factorial? Bro, you don't have, okay, probably no, but probably not factorial, but anything different than factorial is probably would have been fine. So let's try to use this approach. Let's review this approach. We are just creating a new array. Okay, so let's take this, put it here. Let's start from scratch. I don't wanna like um try to fix the previous mistakes because I just wanna reset my mind and start from scratch. It's always difficult to decide between a for and a while. So until when I is to be honest, we just need I to be less than a man, and then we won't do anything after, um, because we will be updating I or J based on some logic. So here in this for, we're just defining I and J, and we're saying the only thing we care is that I should not go over like this. We are just iterating I over this. So first of all, we gotta check if I is greater or equal than m, then check if j is greater or equal than n, and then if otherwise, okay, let's say this, then in this case we'll do something else, and then in this case, like we will have three cases. So let's try, what are we gonna do here? So here, if I is bigger than m, then we will just say nums I, nums1, I is equal to val1, nums val1 is equal to nums1, nums val2 is equal to nums2j. So in this case, when I is outside of the original array, we just want to put the like whatever is in the in nums2, which is val2, and then we will also increase j. And by the way, I'm writing pseudocode, but we can start actually implementing this. Then we said else if j, so in this case, if j is outside of the array, we just like we need to keep the value that we have in um, nums. And by the way, sorry, this is a new array. So um, result is, I don't know how to do this in a single line. Result lens, if I'm not wrong, it's push 0. Okay, so here we create the new array, and then we just say, okay, I iterates over the new array. Does it? I iterates over the first array. It's k. Okay, let's introduce k. So k will be our current iterator of the result array. And we need k to be lesser equal than m. And now we can just increase k without any issues. And then I and j will control the first and the second arrays. So in this case, we just say result k is equal to val1, and then plus I. Cool. Otherwise, okay, in this branch, we know that I and j are both inside the array. So we need to compare the elements. So let's say that val1 is less or equal than val2. In this case, result k will be val1. And we will, so we will be in this case, basically. Otherwise, if val2, in that case, we will just have this. Finally, we can go over, like, to be honest, we don't even need to do this. We can just push. I don't know if that's cheating. Like, we can just push. Yeah, let's do that. We can just push the result here. This is val1. This is val1. Cool. You don't need to create this. Yeah. Awesome. And now that we have this array, after like iterating over it and creating this new array, we can probably just do that again. This time we only need k. We can call it I, but we don't care. And then we can just say nums1k is equal to results k. Result. And we should be good to go. Something I usually do after writing the code is to go over it one more time, looking for bugs. You should go over it thinking that there is even if it's 100% correct, think that there is a bug, like convince yourself that there is a bug you're trying to spot, and try to find if you can find a bug. So let's try to pretend that there is a bug. So we create the new array. And by the way, this is also useful for the interviewer because like that might be a little bit lost after like you writing the program. So this way you just explain them what you've done. So here we create the new result array. We go from k equals 0 to k equals n plus n minus 1. We increase k. Then we take val1 and val2, which is I and j, nums1 I and nums1 j. So I um, um, iterates over nums1 and j iterates over nums2. They both start from 0. So if I is outside, so this is M, size M. If I is outside of M, we just take whatever is J, which is nums2. So we push value 2. Okay, these um we found there is a bug, which is not a bug because we are using JavaScript, TypeScript, but it can be a bug in other languages. And the bug is that we are trying to access nums to j before checking if j is inside the array. So usually in other languages, this would be out of bound exception, something like that. So let's try to generalize this program to be executed in any language. And so we can say that val1, so val2. So we only evaluate val1 and val2 if they are inside their, oh my gosh. And I don't know what's going on. I think it's the fifth time that I like press run by mistake. I don't know what's up. Um, did I press run? Yeah, it was a run. Okay. Uh, so we know there are no bugs, but let's just try to keep going. Um, all right, we have val1 and val2. So what do we do? If j is more than n, we just take whatever it's in in nums1 at I, and then we increase I. In this case, we take nums2 and then we increase j, and then we do the same basically. We do whatever it's here, here, and here, based on whether val1 and val2, like what's the smallest one. And then we just update the original array. And then if we try to run these, that's accepted. And if we submit these, so what is this? Structure progress? Start the study plan? No. Okay, so let's see how other people implemented this solution. Okay, so there is okay, so this approach uses a time complexity of n log n, which is the complexity that I was talking about at the beginning. Let's see. And these, oh, interesting. So we can do this with the space complexity of 1. So this is what I was trying to do before, but I couldn't. So let's see how they implemented this. Because this is very interesting. And we can use JavaScript. And this seems to be way like cleaner and better than what I implemented, which is super cool. Also, I mean, I would not recommend using like I would try to be as explicit as possible. Like in this case, of course, I could have done J plus plus, removing these. This would have been less lines of code. I don't recommend doing that during an interview because, first of all, I don't recommend that in general. This is hard to debug. This is hard to understand. Uh, I mean, in this case, it's not that hard, but like Usually more code um, is better. That's not entirely true, but let's say it is. In this case, I would just put k minus minus after assigning this. And also during an interview, don't use like one-liners. Those are the most hated things by the interviewers. During the one of the times I was being interviewed, I asked how many features of Python I could have used um, to solve that problem, and they said you can use Python features, just don't use one-liners. Like, don't solve the problem in one single line using that's hackish. So don't, or maybe instead of not doing that, just ask before if you can do it. Okay, so what we are doing here, while j is lesser or equal to 0, and j is n minus 1. So j, let's say we have, let's go back to our approach. Um, j would be, let's just take a new one. So j is n minus 1. So j is over here. And then we put j here. I is m minus 1, so I will be here. Actually, let's have single digit numbers. And k is m plus n minus 1. K is gonna be m plus n minus 1. So k is gonna be here. So while j is greater or equal than 0, this makes... Okay, so I was trying to solve this problem from the beginning to the end. Like I was iterating this array from the start to the end. They this is smart, because if you do it the other way around, you can, like, this is already sorted. So let's see what they do after. If I is greater than 0 and these, okay, so if these is nums1 I is greater than nums2 j, is this greater? Yeah, it's greater. So what do? We put nums1, I hate this. So this means that nums1, and then we do k minus minus and I minus. So in k, we put 9. Oh, I see what you're doing. You put 9 in k. And then k goes here. Yeah, it makes sense. K goes here, and I goes here. So basically, just like this is nothing. It's like the zeros. Okay. I mean, technically we still have 9 here, but we don't care. That's just something we will replace in the future. Um, and then we do that again. So which one is? So you go the other way around. So which one is high? Which one is higher? 7. So we put 7 here, and then we keep going. Which one is higher? In this case, 6 is higher. So we put 6. So I guess we put in nums1, we put nums2 j. So we put j here, and then we go back, and this becomes like nothing. And then we keep doing this. So we basically sort in place. This is very smart. This is like the, of course, this is the optimal solution, the best you can aim to. So I'm gonna tell you how what would have happened during my interview. So two things could have happened. The first one, before implementing this solution, the interviewer would have told me that there was a better approach, and would have asked me to implement that approach. In that case, I would have spent more time trying to think how to implement that. And probably with the help of the interviewer. One very important thing is that interviewers are going, like 99% of the interviewers are going to help you. So don't be afraid of asking questions. If they, like, if it's like, if you're asking for the solution, of course, don't ask for the solution. One option would have been the interviewer told me that there was a better solution before starting implementing this. The second option would have been they would have let me code these, and then when finished, they would have asked me what was the um, if there was a best approach, what would have been, and probably to implement that approach instead, if there was still time. So something to keep in mind is that most likely um, they will have follow-up questions. If you're not implementing the best solution, they will ask for the best solution. If you're already implementing the best solution, they will ask for more questions when you finish like writing the code, which is always a good thing. Try to be quick. Don't be too quick making mistakes, but like try to be quick. Don't think that like if you have, I don't know, 45 minutes, try to spend less time. Try to be done with the problem before those 45 minutes, like maybe 10 minutes before, because most likely they will ask you more questions. And that will be a very good thing.